Okay, so we've got our food container positioned over the 2 cups. I can tell that hot water is hot enough because I can see condensation forming on the bottom of the container. Might just add a little bit more room temperature water to that just to get it nicely full. Don't want to add it too quickly because that would create a current in the water. Okay. Now, what I'm going to do is I'm going to take one of my ice cubes and position that over this side, over the blue cooler cup, and then while that is still thawing, and you can see that blue food colouring already falling to the bottom of the container, over on this side, just wipe that off. I don't want any food colouring on the outside of the applicator yet. Push that all the way to the bottom and start to squeeze. And what we should see is that the red food colouring is going to rise while the blue food colouring is falling. I'm going to take that out now very gently. I don't want to create a current in the water. And let's have a look at what's happening. Right, so that ice cube has come loose unfortunately, but it's staying right where it is, so that's good. So you can see the blue food colouring is always falling to the bottom of the container. That's moving around a little bit because I'm moving the table. On the other side, the red food colouring has risen off the bottom, and it is actually moving across. See how it's moving across to the other side? Now this is because we've created a convection current in the water. Here's what's happening. The water on this side, where we've got the ice cube, that water is cooling down. Now as it cools, it condenses, it becomes thicker. So the same weight, but in a smaller space. That causes it to fall towards the bottom of the container. Now over on the other side, the water above the red cup has been heating up. Now this is the same principle as the hot air balloon. We heat the air inside the balloon, that air expands, it keeps the same weight but in a much greater space, and that is why the balloon lifts up into the air. So we've got the same thing happening over here. The water above this cup has been heating up and expanding and rising, and that's created a current. So this blue water is falling. As this water rises, it drags the blue water over to take its place. At the same time, the water falling over here is dragging the red colouring over to take its place. And so we have this continuous current going on. Now, sometimes you will be lucky and you'll get the red rising all the way to the top of the container. But even if it doesn't do that, you can still be showing the kids, look, the red colouring started over here and yet it has moved all the way across to this side. Whereas the blue has moved all the way across to this side, travelling along the bottom. This is an example of a convection current at work, and it is the same sort of principle that we have in our atmosphere to create wind. Basically, gas acts as a fluid, which means it has some of the same essential properties as the liquid water, and you get these currents forming and hotter air rising, cooler air falling. The whole thing pulls the atmosphere around, and that is why we get wind.